Good morning, scholars, and welcome to Tuesday. We are continuing what we were learning yesterday. Yesterday we did frequency tables and dot plots. Today we're going to do frequency tables and histograms. Frequency tables and histograms. Now, a histogram is a visual representation or a graph of the total number of values or frequency in an interval. Okay? An interval is just a section of numbers, and we have a bottom part of that interval and we have a top part of that interval. So maybe the interval goes from 1 to 10. Maybe the interval goes from 15 to 20. Okay, so those sections of numbers would be an interval. You're going to think that a histogram is the same thing as a bar graph. Histograms and bar graphs are related, but they are not the same thing. While on the x-axis, bar graphs have categories such as favorite color, favorite animal, favorite food, favorite ice cream flavor. Histograms have those intervals on the bottom, so they have numbers on that x-axis instead of categories. So let's take a look at this example 1 and show how we can make this frequency table and then relate it into a histogram. The boys and girls basketball teams at Roosevelt Middle School wanted to raise money to help buy new uniforms. They decided to sell baseball caps with the school logo on the front to family members and other interested fans. To obtain the correct cap size, students had to measure the head circumference, distance around the head, of the adults who wanted to order a cap. The following data set represents the head circumferences in millimeters of the adults. So here's that data set of all those head circumferences. The caps come in sizes: extra small, small, medium, large, and extra, extra large. Each cap size covers an interval of head circumferences. That means it's going to go from a bottom number to a top number. And then the next interval will pick up where that first interval left off. The cap manufacturer gave students the table below that shows the interval of head circumferences for each cap size. The interval 510 dash, and then that symbol 530, represents the head circumferences from 510 to 530, not including 530. So this interval means that it includes the bottom number, but does not include the top number. Okay? So we see in this table, we have our cap sizes: extra small, small, medium, large, extra, extra large. And then we have our interval of head circumferences. So basically what we need to do is we're going to take all of these numbers in this data set and we're going to figure out where they fit in. Okay? For example, 513 is in between 510 and 530. So 513 is actually going to be an extra small. 525, you would also wear an extra small. 531, since that's bigger than 530, we need to go the next size up, and we need to go to a small. 533 is also a small. 535 again. 542, 543, 546, 549. 551 is bigger than 550, so we need to go up to a medium there. 552, 552, 553, 554, 555, 560, 561, 563, 563 again, 563 again, 565, 565, 568, 568. 571 is bigger than 570, so we need to go up a size to that large. We see two 571s, 574, a 577, a 580, 583, 583, 584, and 585. All right, 591 is bigger than 590, so we need to go up a size to an extra large because an extra large goes from 590 to 610. Okay, so 591 is in that interval, 595 is in that interval, 598 is in that interval, 603 is still in that interval, 612 is not, but 612 ends up in that extra large interval along with 618. So it's very, very similar to what we did yesterday, except we're not recording specific numbers. We're recording what interval these numbers would go into. Basically, if your head was that size, what size hat would you wear? That's what we're doing. And now we can count up the frequency. There's 2 who would wear an extra small, 8 who would wear a small, 15 who would wear a medium, 9 who would wear a large, 4 who would wear an extra large, and 2 who would wear an extra large. So now that we have this frequency table built out, we can actually go ahead and put it on our histogram. And actually the first 2 bars have already been made for us. So this right here from 510 to 530 is that extra small, and we can see that the bar already goes up to 2 and is shaded in. Now, because histograms are on intervals and one interval picks up exactly where the last interval left off, the bars actually need to be touching. So make sure when you're making a histogram that your bars are touching. From 530 to 550, that's the small size. If we go up to small, there were 8 in the small, and it's already done for us. From 550 to 570, what size is that? Right, that's our medium size. There were 15 in medium, so I'm going to go up. I don't see a 15, but I know that 15 is in between 14 and 16. So I'm going to put a line in the middle of 14 and 16. And I'm going to go ahead and come all the way down. And there's my bar for medium. And I'll go ahead and shade it in. All right. From 570 to 590, that's our large size. There are 9 in the large. Once again, I don't see a 9, but I know 9 is between 8 and 10. So I'm going to go up right between 8 and 10, make my line across and down, and make sure that the bars are touching. Make sure that those bars are touching. From 590 to 610, that is our extra large size. And there are 4 who need an extra large. So we're going to go up to 4 and make our bar. And then from 610 to 630, that's our extra large size. And only 2 people needed that. And there is our histogram. The bars reach up to the frequencies. So the bars in a histogram represent the frequency. And down here are the intervals. We have our frequency on the y-axis and our intervals on the x-axis. Now, histograms and dot plots are very, very similar, where the points that go up represent the frequency and the x-axis represents a number line of some sort. Okay? So let's talk about some situations where you would use dot plots versus histograms. Okay? So, dot plots are really great for knowing specific numbers. What we can see in our histogram here is it just kind of the specific numbers got lost. We know the different sizes that each person needs, but we no longer know specific head circumferences, which is fine in this situation because we really only need to know what hat size somebody needs. But in other situations, that wouldn't be so good. So if you were to talk about our example from yesterday, hours of sleep, right? Hours of sleep, we wouldn't want to talk about specifics. We would want to talk about specifics with maybe how tall somebody is if we're trying to figure out like the tallest person, the shortest person, that sort of thing. And we're trying to plot those specific numbers. We would want to use a dot plot. Dot plots are also great for a smaller sample size. So if I'm polling 20 people, I could use a dot plot. If I'm polling 10 people, I would use a dot plot. However, with those larger sample sizes, I would want to use a histogram. Here's why. If I give 200 people a survey, I don't want to draw 200 dots. I don't have time to draw 200 dots. I don't have the energy to draw 200 dots. And I know y'all aren't wanting to draw 200 dots either. So a histogram is really great for that. We just pick an interval. 10s, 20s, 5s are normally really good. And we would put those numbers on an interval. And anything that isn't number specific. So not number specific is really great for a histogram. Okay. So if I were to ask how many people needed a large to extra large size, we would want to look at this entire interval from large to extra large, and we would want to count all of those people. So that's 9, 4, and 2. 9 plus 4 plus 2 is 15. So 15 people need a large from extra large size. And that's all I have on histograms. You're going to continue going through and you're going to learn about the different shapes of a distribution. And you're going to get some practice problems with making histograms. So go ahead and go through the rest of the form. And I will see you guys later.